Now see, we start with Standard 11, Semester 1, Chapter number 8, that is linear inequalities. Linear inequalities. Now before we start linear inequality, first try to understand what do you mean by inequalities. Suppose you are given AB belongs to R. Then there are three possibilities between two real numbers. A can be equal to B, or A can be less than B, or A can be greater than B. This, if A is not B, then A less than B or A greater than B. These two are called strict inequalities. Strict inequalities. I can also write down this inequality in this form, A less than or equal to B. It implies A less than B or A equal to B. I can write inequality like this also, A greater than or equal to B. Implies A greater than B or A equal to B. These two are called strict inequality because there is no chance of A and B to be equal. A less than or equal to B means there are two possibilities. A can be equal to B or A can be less than B. Now, for this real number A and B, we have learned in our lower standard some properties. They have given the list of properties. If A greater than B, if and only if A minus B greater than 0. Clear? Second property they have given, A greater than B, A greater than 0, B greater than 0. That implies A plus B greater than 0. Then they have given and AB is also greater than 0. These are the properties you have to keep in your mind. A greater than 0, if and only if minus A less than 0. Clear? Then they have given if A greater than B and C belongs to R, whether positive or negative, then A plus C greater than B plus C. We don't bother about sign. But if A greater than B and C greater than 0, then AC will be greater than BC. But if C less than 0, then AC will be less than BC. If I multiply both sides with a negative number, then my inequality changes. By adding positive and negative doesn't change the inequality, but by multiplying with positive and negative, if by positive, inequality does not change. But if you multiply any number with a negative number, then inequality changes. And then many more. A greater than B, and if B greater than C, implies A greater than C. This is law of transitivity. all this property you have learned in your 8th standard, right? And that we are going to use in 11th science also. Okay. Now, as we have a inequality in real number, we are going to learn linear inequality in one variable. Today we are going to learn solution set of linear inequality in one variable. First of all, I define linear equation in one variable. What is the general form of linear equation in one variable? The general form of linear equation in one variable is ax plus b 0, where AB belongs to R and B is not 0. This is the general form of linear equation in one variable. Instead of x, they can give you y also, t also, u also, v also. Now, the solution of linear equation are always, we can represent the solution on number line. Right? On number line I can represent the solution of linear equation in one variable. X is minus b by. So I have to plot point minus b by on x-axis, okay, on number line. So with respect to this linear equation, we have a 4 linear inequality, like ax plus b is greater than c, or ax plus b is less than c. Suppose this instead of 0, c. ABC belongs to R and A is not 0. This is the general form of linear equation in one variable. Ax plus b is c, or you can take 0 also. So linear inequalities, linear inequation, how many linear equation I can form with the help of this linear equation in one variable? It can be ax plus b greater than c, ax plus b less than c, ax plus b greater than or equal to c, and ax plus b less than or equal to c. 4 types of linear inequation in one variable are available. Now how to plot their graph? Or suppose I can take c 0. If c is 0, then my linear inequality take the form ax plus b greater than 0, or ax plus b less than 0, or ax plus b greater than or equal to 0, or ax plus b. 4 inequalities. Clear? Now we know all the solution of this linear inequalities are on a number line, because we know the value of variable which satisfy the value of variable x, which give this statement, give a true statement from an inequality after substitution, are called solution of the inequalities. All such solution constitute the solution set of linear inequalities. मतलब the set of values, of the variable which gives a true statement from an inequality. after substituting the value is called the solution set. Of the inequality. And that solution set is always a subset of R. R matlab set of real number. You know, there is one correspondence between every values of X which make this statement inequality true as a unique point on a number line. Clear? Now let us start solving some linear inequations in one variable, okay? See, suppose you are given solve for sum 20x plus 9 less than 300. First condition में दिया है for all x belongs to n. सेकंड में दिया है फॉर ऑल एक्स बिलोंग्स टू जेड एंड थर्ड में दिया है फॉर ऑल एक्स बिलोंग्स टू आर. फॉर नहीं, एक्स बिलोंग्स टू एन. You are asked to find out solution when x belongs to n. This equation, I am asked to find out solution set of this equation 20x plus 9 is less than 300, where restriction is given x belongs to n. Second restriction is given x belongs to z. Third restriction given x belongs to R. Matlab my solution should be in R. Now how to solve this? See, if I take 20x, I want to avoid 9, then I have to add minus 9 on both sides. And I know by adding minus 9, inequality does not change. So I got 20x less than 291. So my x will be less than 291 by 20. So it is 14.55. Now how many natural number less than 44.45? The solution set, if x belongs to n, with first condition solution set is set containing 1, 2, 3 up to 13, up to 14, because less than 14.55, how many natural number? 1 to 14. Clear? Suppose it is given belongs to z, then my solution set is, it is my dash 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 minus 3, minus 2, minus 1, 0, 1, 2, 3 up to 14. Clear? And if it is belongs to R, then my solution set is open interval minus infinity to 291 by 20. Clear? This is my answer for third. If x belongs to R, then it's open interval minus infinity to 291 by 20. Matlab, I can write it as set of all x belongs to R such that x is less than 14.55. This way also you can write. Are you clear? How to find out solution of linear inequation in one variable? Here, all these values of given in solution set make my this inequality true. By putting x is 1, it is 20 plus 9. 29 is less than 300. By putting x is 14, right? I will get 280 plus 9. 289 less than 300, like that. So every values of x in a solution set make my inequality true. Clear? Now same way, you are given another sum. Solve 2x minus 3 greater than 5. First condition is given x belongs to n. Second, it is given x belongs to R. First, let me solve this equation. It is 2x greater than 8. So it implies my x greater than 4. 2 is positive. I divide both sides by 2. So I am getting my solution set is x greater than 4. But my restriction is given x belongs to n. So how many natural number are less than greater than 4? No limit. Greater than 4 matlab we start with 5. 5, 6, 7, dash, dash, dash. Matlab all this natural number make my this inequality true. Clear? Clear? Now for this, if x belongs to R, then solution set is set of all x belongs to R such that x greater than 4. Or you can write it as open interval 4 to infinity. Clear? Are you clear how to find out solution set of linear inequality in one variable? Suppose I want to represent this on a number line. This is my number line, this is arbitrary point O, that is 0. All positive on this side, negative on that side. Suppose I want to represent solution of first inequality n belongs to n. So it should be 1, 2, solid point, 3 and up to 14. Suppose you want to represent them for case number 3, x belongs to R. Then I will take a 14.55 hollow point and all the portion less than 14 point. Matlab I should put dark line from 14.55 onwards. This is my shaded solution set. Geometrically I represented my solution set for x belongs to R. This is for x belongs to n. Clear? This I have written algebraically and this I have written geometrically. This I have written algebraically, this I have shaded geometrically. I can represent solution set algebraically also and geometrically also. Clear? Now see third sum. Solve 3 times 2x minus 1 plus 5 less than or equal to 1/2 time x plus 15, and here condition is x belongs to R. I am asked to find out solution set for this inequality algebraically. So I just open it. It is 6x minus 3 plus 5 less than or equal to 1/2 time x plus 15. These two I multiplied both sides by 2. It is 6x plus 2 multiplied by 2. So 12x plus 4 less than or equal to x plus 15. So it implies my 11x, x will be taken this side, 4 will be taken this side, less than or equal to 11. So it implies my x less than or equal to 1. Clear? So less than equal to 1 matlab my solution set is less than equal to 1 matlab left hand side of 1 minus infinity to 1 close at 1. If I want to represent them on number line, this is 0, this is 1. So close at 1, so solid point. Open at 1, then hollow point. Solid point 1 and less than matlab on left hand side. This shaded part on number line represent my solution set on number line. I represented my solution set geometrically on graphical way to represent solution set. Now suppose you are given for sum, solve 3 minus 2x upon 5 less than x by 3 plus 2. I don't know 3 minus 2x is negative or positive, right? So better you take it like this, 3 minus 2x upon 5 minus x by 3 less than 2. Clear? Now take the LCM 15. So here is 15. 3 times 3 minus 2x minus 5x upon 15 less than 2. So it is 9 minus 6x minus 5x less than 30 because 15 is positive. So to take positive number on that side, no problem. So 9 minus 11x less than 30. So my minus 11x less than 21. My minus 11 is negative. So if I divide both sides by minus 11, then my inequality change. This less than is going to become greater than minus 21 by 11. When I take minus 11 on that side, I have given the property A greater than B, but C less than 0. Then AC less than BC. Inequality changes. So my solution set for this is greater than minus 20 by 21 by 11. So greater than matlab on right hand side. So open at minus 21 by 11 and open at infinity. Suppose I want to represent this solution graphically. Minus 21 by 11 is lying between minus 1 to minus 2. It is very near to minus 2. Very near. Suppose this is my minus 21 by 11. But here is greater than. So I have to take hollow point. Minus 21 by 11 is not included. And greater than matlab on right hand side. So I have to make this portion dark. I have to make this portion dark. This is my solution set. I have represented it graphically. On number line, this shaded part represent my solution. Clear? This open interval can be represented on a number line by this way. This is hollow point at minus 21 by 11 because not included. In sum number 3, 1 was included. So I put solid point at 1. Here I put hollow point at minus 21 by 11. Clear? So those properties which I have discussed are going to help in solving linear inequality algebraically.